Okay. Hello, everybody. This is the systems workgroup status and roadmap. It's actually not an update because during the last workshop, we just asked for creating this workgroup, and it was recently founded then in May and June timeframe. So just the first results to show, give you a slight overview on what I will show. So I'll talk shortly about the working group foundation. Then I'll move over to the first starting activities. They include already some very nice work from other communities and show also interaction with other projects. And then how these activities match into the ongoing activities. And afterwards, I give a little bit of roadmap on outlook, and maybe impossible to show how our architecture, which we currently anticipate in this reference system of systems workgroup, how to fit to other use cases and how this could also provide a path forward. Addressing the elephant in the room, which will come over the next time, there's not too much of functional safety work going on here because we mainly work on starting with a reference system. But during the set of the presentation, we'll see how this gives a good fit to the work of other work groups and how we complement the work which is going on there. So just a little bit of what happened in the past. Originally, the proposal request was to form an industrial IoT work group. And while discussing this, we figured out it's maybe more the systems working group, which gets in there. And yeah, we see that the architecture of modern IoT systems, which are basically connected devices and getting complex functionality, map a lot to what we also see in medical, automotive, industrial. So there's a good fit for many different industries. And the idea is then to provide a reproducible reference system. This was also what was proposed during the industrial IoT working group proposal. And what I really like already from the starting time, we had pre-discussions when I asked for getting this industrial IoT working group started. And already now there's contributions from the Xen project, Yocto project, and automotive grade Linux, but they participate really in almost every working group meeting. So this is really nice to see this strong support. We jointly came to working group goals. These goals first of all include that we enable other working groups. So within the ELISA, also related to external projects, but it should bring the work of the Linux features, architecture, automotive, medical devices into the wider system context. We saw this picture in GAP's slide where you see the system boundaries from the analysis, and I guess this is very important to become into a context and have a workbench. And this workbench will be a reproducible reference system, and we want to base it on architectures which can be found in real life. But important for us was to bring it into fully open source technology because in this way there's access for everybody, and I guess it should be common sense anyway of the project charter as we have it for ELISA. And we strongly also encourage the interaction with other communities and projects. So you can already see this, that we have Xen and Yocto maintainer involved in our working group, and also even if it's not directly the use case as AGL has it today, rather we look for the support and the interaction with the AGL folks. So and it should enable safety use cases with open source software. So that's the overall part. How everything started was by the Xen project and basically by Stefano Stabilini. He had a little bit different idea when presenting this during the last Open Source Summit North America. So I put in the link and also the titles. So if you check, there's a beautiful YouTube recording, which is like 50 minutes to tell you what it's all about. He used Xen and RT Linux and Zephyr, and he wanted to put this into a concrete end-to-end example. If you don't want to watch it now, which please don't do, stay in here. the overall content of the demo was to have an end example. So you can see there's the Xen underneath with Linux system 0. There's another domain which is Linux RT and the Zephyr. So it all has core binding on the different CPUs, and there was image build involved for having the bootable configuration, Xen device tree. So there was really the Xen focus in there. And it shows a lot of the important steps which you will need in a later system, like the partitioning of the system, device assignment, cache coloring, core bonding, shared memory, and event channels, PV drivers. So all these parts were in there. And some key messages which he brought across there was, it was quite complicated in the past to do certain things, especially static partitioning was quite hard, and the devices and cache coloring, and the static partitioning also required a lot of experience, and this is now a lot automated, and yeah, it could also illustrate the ability of a real-time interrupt latency for the guests, and also with heavy interferences. So this shows how work cases can be put into practice, and it's really from a customer example. So it's not a made-up use case or something like this. And yeah, I guess we don't have Stefano in today for this, but if there are questions, you can also put them in chat. We can see that we forward, or simply join the systems work group so that we can discuss there. Anyway, the steps which he prepared are documented. You can follow these steps by looking at the recording, but it's not fully automated. So it's in a way reproducible, but it's not in a full tooling. And this brings us a little bit forward to next steps, and we have this ongoing activities. We see that during the work in the working group, we wanted to port this. And we started with porting it to Yocto, but we have also seen there was engagement by other people, like especially EPAM, who is bringing in Morlin from their Xen activities. What Morlin is, you can either follow the link or also wait for the next slide. And this should bring us much closer to full automation of this example, so that you can follow documentation, understand how the system is constructed, and is currently work in progress on the porting. It starts on the Xilinx hardware and QEMU base. The QEMU which Xilinx provides is very close to hardware, so they have a lot of features already in their QEMU simulation. So in theory, you can just simply take whatever you've built for the QEMU. And sorry for this, go once back. Right, was interrupted. Right, this was the main work. So they did this, and then the next step was to populate the results in the GitHub repo for all this glue logic and configuration. That's the missing part, which we currently have from the EPAM work, and also extending it to Yocto. Then, yeah, there's the idea of having an additional hardware in there, and not only having the QEMU-based simulation, as I just mentioned, from the Xilinx part. And the last thing to mention, which is an ongoing activity, it's spin-off, so to say. There's the SBOM generation, because we have also discussed about how to generate the SBOM from the use case, how to bring this properly in, and then there were an outreach to the SPDX. So there's a new SPDX user special interest group branch, and I also have a slide for this. So the next thing is the full automation of the example using Morlin. I just put a quote in there. Morlin is a meta build system that's capable of building multiple and complex images for embedded devices at once. This means this works for Android, Linux as such, the Xen, and it also has certain support for Zephyr. Underneath there is the Ninja engine used, and yeah, so far the Xilinx ZCU1 is supported, and the work in progress also has different domains built. There's also the idea to replace the DOM0 and have DOM0 less or DOM0 Linux replaced Sapphire. Different steps are going on here. That's a work in progress. You can see the state under the current contribution GitHub repo part before it turns into a merge also and getting linked by the systems work with GitHub. Right. A few words about the new SPDX, who's a special interest group. Basically, the idea is to have a safety case model defined by SPDX tags. And you can imagine the whole thing that whenever there are changes, sure was stressing is doing the introduction on there are changes in the system. We have continuous updates for security features, whatever comes in a Linux system and also in other systems overall. And for this, the idea is to create traceability metrics, to have the relationship we will set up and getting really automated safety case generation. And here, of course, it's very good if you have an exchangeable format and do this in projects such as SPDX. There is the regular call for it and the mailing list. So basically, if you follow here the QR code again, you will end up at the site, and you can also figure out the link to the meeting minutes. And it was really nice because, as I said, we would like to have this collaboration approach. And yeah, it was just some discussion which came up, and there was suddenly a strong interest, and it was not the right forum directly to do this in the system work group. In the weekly discussion and with SPDX, we have a very good place to discuss this and to still bridge it and bring it into the systems work group for ELISA. So, and gain benefits on both sides. Right. What's a little bit pending is we have really to do a roadmap on this to come to a better idea on the work packages, because we have a lot of work to do, but it's hard to assign tasks to someone and ask for volunteers if you cannot directly say, this is exactly the task or the topic which need to be addressed. So we'll break down the topics in the Manchester workshop, which comes in over next week, and then hopefully have a good set there and also provide an idea how the work group will evolve over the next years. For this, it's important to interact with the other ELISA working groups and also interacting with open source communities, with general community safety critical open source communities. And yeah, some of the tasks which are discussed also is then how to bring the use cases. I made a sketch draft on where things get in. So we have the Linux features architecture code improvement work group, tool investigation, and the code improvement part will most likely end up in the Linux domain directly, along with the use cases, architecture results, certain features which are done by the group of Ilana in the Linux features group. And yeah, we have open source engineering process. All I hope you excuse that I just put it to the tooling. Of course, it's much more, right? It's going into different levels, going into the kernel. We do a lot of analysis, but I found it also a good place to put there because it's the methodology which is also applied there and brings it closer to real world life. Yeah, the tool investigation, of course, also goes into the tooling as they set up server and so on. And with the use cases from medical, automotive, let's see if we have the aerospace onto which later on in the schedule. So this is where we would like to see how does it fit. And the idea is to scale out maybe what is there to create a subset of the system, use a system as such, and see how this can work with different use cases. Because the overall idea is really that you can take this, what comes out of the systems work group, and you know how to create a SBOM, how to get started, how to apply a feature and analyze this in a working set, and maybe then we can strip down certain kernel configuration, enable features, put them out. And if you come and you're brave or less brave, you can also say that certain functionality go into still an RTOS, how you may set up either on a microcontroller or in a virtualized domain, and see then the interaction of different areas and really have something for practical experience of the whole thing, right? To be able to also talk with other operating system, like with Xen for the hypervisor discussion, inter-core, inter-process communication, also with the artists, we need to reach out to communities. And for this, yeah, we have already good contact to the Xen community. This is really, really good. I guess we need to extend also to have stronger interaction with Zephyr. We have already branched in there. We have expertise from engineers in there, but there is not the direct community outreach on this fully established. And if you see beside the automotive grade Linux, there are also other projects which have safety critical relevance and going more into the connected vehicle computing, centralized computing in cars, for example, which is with Sophie, driven by ARM, and the SDV, Software-Defined Vehicle Eclipse Foundation initiative project, which is information which looks to a comparable architecture with also having hypervisor and container technology, arches, and Linux subsystem. And I like this post from George Bernard Shaw, who said if you have one apple and you exchange the apple with someone else who also has an apple, then each still has one apple. But this is really about, in the end, creating robust, reliable, real world use cases which are getting closer to being able to be used in safety certification and enable the system. And by this, the idea is the discussion with related projects which share similar burden and challenges is crucial for this work group. Right. As we already have some support for especially the work on Xen and building up the small, and we still also miss some support. So as said, we need to look into the workshop in Manchester, but to just give already a first glimpse on the idea where it really makes sense is to also have an end-to-end example with Yocto, so that we have basically a choice between Molin and Yocto and see that the concept works with both. We're looking into how to get, for example, also the automotive grade Linux in rather than having the Linux RT from the original demo. And what could also be an option is to take an Apertus shot in there, because this is a Debian-based Linux automotive distro with similar ideas as AGL. The alternative hardware for sure, because not everybody has Xilinx, and if you want to show something, it's much nicer to not go only for the demo. So with QEMU, we're considering things like maybe Renesas RCAR3 or IMXA could be an option. So when you see what hardware could work in, maybe even a Raspberry Pi can be an option to have a widespread hardware. We're evaluating this and basically looking also for volunteers to drive, maybe to port the demo on a different platform. And yeah, what would be also great, we have the special interest group on the SBOM activities, but it's not really bringing this whole thing into the this reference system. And for this, to also try out the SBOM generation, for example, fully with Yocto, because there are features in there to build then the Yocto, with the Yocto, the Zephyr, and Linux, and then create the full system SBOM, check how container can be incorporated in there and how container SBOM is generated. This is also a nice topic. And as I said, we try to make more things out of this. Right. Just to see why we do this, as in the beginning, I said we want to have a workbench for safety critical workloads, but also for workloads in principle, and have a reference architecture ecosystem from the real world example. And by going with, for example, Yocto and Molin, we have more flexible part how to get properly into CI, CD, CT, with doing different Linux flavors of Yocto and Debian. It's maybe easier in the end also for others to have more choices and taking own Linux elements in there. Hardware, as I said, this also the QEMU we will definitely take, because it's strong benefit for just doing CI/CD testing and bringing things in. But if you go on a fair, if you want to showcase something and if you want to get hands-on, there's some functionality maybe also just available in hardware. So it's a good idea to also scale this so that it's a guide there how to bring one hardware to the other. And then SBOM already mentioned shortly, and yeah, with Zephyr and Xen, we're coming much closer to how real-world examples look like. Maybe we'll also see what alternatives could be in there for Zephyr, Xen, but for now, I guess it's enough work to do to go like this. And if we all do this, we have quite a scalable architecture in hand. And when I started or asked for the request for the work group, we started to talk about maybe a vacuum cleaner as a use case, a robot vacuum cleaner or a robot lawnmower. And this is already a system which looks very similar compared to a larger vehicle, to stronger devices from industrial manufacturing also. And yes, we're starting with a use case with limited safety criticality. I guess for a vacuum cleaner, there's almost no safety criticality in there, but you need to be careful with your pets maybe, but that's the only part in there, not for a human loss or so. And yeah, but it can be done step by step. And I guess here the other work groups doing a big step forward also. And by interacting with the other LeanIR work groups, this gets us a way forward. And here, so I just want to show the story. So if we think about this architecture, and if you have an autonomous driving lawnmower or also vacuum cleaner, then you already now have items like mining and agriculture, which is a controlled environment, and more the large scale of a vacuum cleaner and a lawnmower. So this gives us still a controlled environment with different safety standards, which may not be an ISO 26262 for the automotive part. And then we can even scale up how to put this in complex system architectures for autonomous driving. So for me, it was important to show this path, and that there's a linkage between how can a little vacuum cleaner with sensors, actuators, and driving autonomous give a track towards some autonomous vehicles and larger scale safety criticality use cases. Right, with this, I still have a few minutes left, so I want to put a stress to join the working group, join forces, and yeah, the mailing list up there with weekly meetings. We meet on Mondays, European evening time. So for US, it's easier to join. For Asia, it's hard. So if we have people from Asia in who have interest, let me know. We found also good solutions for the automotive work group. The minutes are public. You can all take them up, and you get all the information if you scan the QR code again to join. And yeah, then you get the links to the direct ELISA lists. And we're done basically. So let's see if there are some questions. I'm looking forward to them. And also if you would like to join the mailing list or come to our meetings, I'd appreciate it. Thank you.
Looking to see if there's any questions. There's nothing in the chat.